Hi everybody and welcome to the short presentation of the EHDO tool. EHDO is a free web tool for planning and designing complex energy systems. For efficient energy supply systems, the coupling of different energy sectors such as heating, cooling and electricity is of great importance. Sustainable energy systems often comprise renewable energies, energy storages or energy carriers like biomass and hydrogen. In the early planning phase of an energy supply system for building or a district, EHDO provides a first estimation of the optimal system configuration and dimensioning, as well as the system's profitability. So let's have a closer look at the tool. On the EHDO webpage, we can start a new calculation by clicking on New Optimization Scenario. The input page of the tool has three tabs: Demands and Location, Technologies, and Model Parameters. In the first tab, we define the energy demands that shall be covered by the energy system. They can include heating, cooling, electricity, and hydrogen demands. At the bottom of the page, we select the geographic location of the system. The location is relevant for the calculation of renewable energies with weather data, like solar radiation and wind speed. In the tool, data for more than 100 cities worldwide are available. In the second tab, Technologies, we define which generation and storage technologies we want to consider in the optimization. These include technologies to use renewable energies like photovoltaic modules, wind turbines, hydroelectricity, or solar thermal collectors. Conventional heating and cooling technologies like heat pump, electric resistance heater, or compression and absorption chiller. Gas-driven technologies such as combined heat and power unit, gas boiler, or gas heat pump. Combined heat and power unit and boiler fired with biomass or waste. Hydrogen technologies such as electrolyzer, fuel cell, hydrogen storage and Sabatier reactor. And finally, conventional energy storages like heat and cold storages, batteries and gas storages. In the third tab, Model Parameters, we define general input parameters like electricity and gas prices or CO2 tax. Here we can also define a reference system to which we want to compare the performance of the optimized system. If everything is set, we can start the optimization process with the button Run Optimization. The optimization takes about 1 to 2 minutes depending on the system complexity. After the optimization is finished, the results are summarized on the result page. At the top of the page, we can find a calculation ID. With this ID, the calculation scenario can be reloaded later, parameters can be adjusted, and thus parameter studies can be conducted. In the first result section, we can see the optimal system configuration with the optimal generation and storage capacities. Furthermore, we find information about imported energy, for example from the electricity or gas grid, and how much electricity is generated by renewable energies. In the next section, we see the different cost proportion of the system, including annualized investments and energy supply costs, such as electricity costs. In addition, the annual CO2 emission of the system are listed, and in the subsequent section, a comparison with the reference system regarding efficiency and profitability is provided. In the last two sections, the heating, cooling, electricity and hydrogen demands that we defined on the input page are visualized, and an overview of renewable energy resources used in the system is provided. Of course, all parameters of the optimization, like specific investment costs and conversion efficiencies, can be tailored to an individual use case. Alright, I hope you got an idea how EHDO can be used to design complex energy supply systems, and we would be happy if the tool can also help in the planning process of your energy system. If you want to learn more about the EHDO tool, the techno-economic optimization approach, and the different settings of the tool, please also watch the detailed user tutorials. Thanks for watching.